Welcome back. As I mentioned last time, we've created our board and our game object. Now it's time to create our markers, our X and our O. And so our X extends our playfield object. Its init method says I'm going to get a board, the place where I'm going to be playing the game. I want to position it on some row and then I call the init method, which is the init method for the playfield object to tell what playfield we're playing on, what our name is, our default color, our X and Y coordinate, and our height and our width. And mind you, we're getting the height and the width from the board itself, the board that we just created. And now that we also need to add the board to this object, and then we're going to move the object to its position at row and column. That's the initialization for the X object. To draw an X object, we just create a line from its X coordinate and Y coordinate to the X coordinate plus its width and the Y coordinate plus its height. And we do that again, but we do it in the opposite direction. Now, when we move this object, we don't want to specify the actual X, Y pixel coordinates on the screen. We want to talk about rows and columns because in the universe of tic-tac-toe, we don't really know anything about pixels. All we really know about is cells, which are the rows and the columns of our tic-tac-toe board. And so we need to translate rows and columns into pixels. And if this board were always 256 by 256, then we could specify which pixel coordinate we wanted. But if we, for whatever reason, decide to make it 512 by 512, we'd have to rewrite our entire application to accommodate that change. What we're doing instead is that we're grabbing the height of this object, which we specified as being the cell height, and multiplying the row by that height. If it's row 0, column 0, the X and Y coordinate in pixels is going to be 0, 0. But if we put the X here at cell 1, 1, then it's going to be height, which is in this case 1/3 of 5. What we're going to do instead is we're going to multiply it by its height. And the height in this case is 1/3 of 512, which happens to be about 171. We don't want to draw this at pixel location 171, but we want to multiply the row that we've selected, which is row 1, times the height, which is going to move us down 171 pixels. Likewise, the X location is going to take the column and multiply it by its width, which happens to also be 171, and it's going to position it right here and draw our X in the middle square. And then we also want to store off the row and the column as being this row and this column. And so this completes the X object. Let's go back to our game board and let's add it in. We're going to add in our first X object. I'm creating it on this board and it's at location rows 1, column 1. So let's refresh and there it shows up in the middle. Now, if I wanted this to be in, say, row 2, column 0, refresh, would show up down here. That's how we create the X object. Now, let's go back and let's create the O object. It's going to look just like the X object. Okay, except when we draw it, we want to draw a circle. Okay, and we draw it at the X location of our and Y location of our object, of our circle, and then its width divided by 2 is its radius, and we will make this the the O object. And then let's go back to the game and let's add that one in. Again, we're not going to keep these particular X and O objects. We're just testing to make sure that they work. And I'm going to put this at 1, 1 and refresh. And there's our O. If you remember from the JavaScript tutorial that I did when we introduced playfield objects, we learned about keeping our code dry. Whenever we see a duplication of code like we have here, it implies that there's some higher level parent object that we can create that holds all of this information that so that we don't have to repeat ourselves. What I'm going to do now, so we're going to create a superclass that we're going to call piece. And a piece is something that is either an X or an O object. Now, let's take a look at everything that we're going to keep. For one thing, both the X and the Y objects do the same initialization. They have the same move function. And the only thing that's different between them is their draw function. We probably have a slightly different initialization based on the fact that it's an X as opposed to being a playfield object. I'm just going to go ahead and copy this X object. We don't need to capture the same information that we did before. What we're going to have is a board and a row and a column as our arguments. And then we're going to call our superclass, which in this case is piece. And we're going to keep a value. We're going to keep track of what type of a piece this is, and it's the X. That's different from the Y. Okay, or different from the O. Okay, and the X doesn't need this move method because it's inheriting from the piece. That's a big change, but you can see that we've simplified things. Every piece, no matter whether it's an X or O, has the same initialization. That is that we have to figure out what board it is. We have to move it and position it on the board. They both share the same move function, so there's no need to repeat that. Down here, the X has its own initialization and its own draw function. Let's test that, make sure we haven't broken anything. Good. Things are still working. Our X still shows up, but now we need to generalize the O object to be a piece. Like that factory method. And it has the same sort of initialization as our X object, which is pretty much just do whatever it is that any generic piece would do. It's the same initialization, but when we keep its value, it's going to be a value of Y. And again, we don't need this move method in here. Okay, we have very succinctly described what an X looks like. It is a piece. It has a little bit of initialization and a draw function. Oh, I made a little bit of a bug here. Now it's working fine. We've now created our pieces. Our next step is to actually allow some user interaction where we can position pieces with our mouse. Let's look at that next.